we're going to look at solving the system from last week that we did in our check-in. So we already know the answer is going to be 5, 1, but we're going to use a different method, and it wants us to use the matrix equation. So remember, if we write out our matrices, or actually our system, using these matrices A, X, and B, where A is the coefficient matrix, X is the variable matrix, and B is kind of the answer part. I can write it here. It would be 1, 1, 2, negative 1. X, Y is equal to B being that 6, 9. And so what we have talked about is that since we have the inverse matrix, we can actually kind of deal with the matrix equation and isolate this X, which is really going to solve for X and Y. So if I take A inverse times that A, and let's do it on both sides to maintain that balance, what we're going to have then is that X, that matrix X, is going to be equal to whatever the inverse of A is times B. So again, this is matrix A, this is our matrix X, and this is matrix B. So if I can figure out A inverse, then all I got to do is multiply it by that B, and I'll have my solution. So remember, if we want to find the inverse of a 2 by 2 matrix, it's really 1 over the determinant of A times, and this is where we're going to flip-flop the A and the C. So we're going to have DA. This is our A, B, C, D matrix. And we're going to take the opposite of what's in spot B and the opposite of what's in spot C. And so for our determinant, remember, it's going to be the diagonal minus the other diagonal. So 1 times negative 1 minus 1 times 2. So that's negative 1 minus 2, so negative 3 is our determinant. So this is going to be 1 over negative 3. We're going to multiply that scalar times, alright, well, let's interchange our A and our D. That's going to be negative 1, 1. And then we're going to take the opposite of our B, that'll be a negative 1, the opposite of our C, which will be negative 2. And so when we multiply this scalar in, each of our terms inside this matrix will get multiplied by a negative 1/3. So we're going to have 1/3 positive, another positive 1/3. On the bottom we'll get positive 2/3, and then we'll get negative 1/3. So this is our inverse matrix. Now we're not done yet. We haven't actually solved the system. So what we're going to do, again, is if we want to find the matrix XY, or that has the elements X and Y in it, matrix X is found by taking the inverse, which we just found, times B. So matrix A is 1/3, or A inverse is 1/3, 1/3, 2/3, negative 1/3. And we're going to multiply this by matrix B, which is 6, 9. And remember the way that matrix multiplication works. You take a row here times this column, and so it's going to be 1/3 times the 6. Those two go together. And then 1/3 times the 9. We're going to add those together. And then for our second row, still times that only one column we have there, we're going to have 2/3 times 6 plus the negative 1/3 times the 9. So again, this first term here multiplies with 6, and then that multiplies with 9. And so our matrix is still going to be just one column, because again, this was a 2 by 2, this is a 2 by 1, so it ends up being a 2 by 1 matrix, 2 rows, 1 column. And so we're going to have here, if we multiply, we'll have 6/3 plus 9/3, which will be equal to 15/3. So this together is 15/3, which is 5. And then in the bottom, we're going to have, this will be 12/3 minus 9/3. Well, that's going to be really 3/3, which is 1. So we're going to get 5, 1, which again, this is corresponding to our X, and this is corresponding to our Y. Or you can write it as an ordered pair, 5, 1, which again matches up from what we got last week. So this is just a different method for solving the system.